Hello, can ref output quality scores be assigned by AI? This presentation summarises our recommendations, and the full report can be found at the URL below. The project goal and methods. We had a specific goal to assess whether AI could inform or replace human assessors for journal articles in future research excellence frameworks. To do this, the data we were given was provisional access to REF 2021 journal article scores for 2 months between March and May 2022, so they've now been deleted. And the methods we used were: first, we tested the accuracy of thousands of combinations of different machine learning algorithms, inputs and broad strategies. And then we showed the results to groups of REF assessors from most REF 2021 units of assessment subpanels, including chairs, to get their feedback on the level of accuracy achievable by the AI. So this presentation summarises the recommendations first and then gives some background about them afterwards. So the first question was, can all REF outputs be scored by AI next time? So get rid of the 1,000+ human assessors, save all their time and have a computer instead. The answer is no, unsurprisingly perhaps. And the reason is because, first of all, AI is not clever enough to logically deduce the quality of an article. And although it is true that AI can learn to estimate REF output scores if fed with lots of examples of already scored outputs, the accuracy isn't high enough, and it also decreases over time. So a system built from REF 2021 scores would be very inaccurate for REF 2028. So we definitely need the human assessors next time. The second question was, could some REF outputs be scored by AI next time? So not all of them, but some of them. In other words, could we let the panel members score half of the journal articles, for example, and let the AI score the rest, or take some proportion that's scored by the humans and another proportion scored by the AI? And the answer is still no, because the AI estimates are still not accurate enough. By not accurate enough, I mean that the score shifts that would be induced by changing some of the scores from human to AI are still too large to be acceptable to REF 2021 subpanel members. Next question was, could we use the AI REF score predictions as evidence for peer review? In other words, could we supply REF 2028 panel members with AI score predictions instead of the bibliometrics, or as well as the bibliometrics, in order to help them make their decisions on outputs? And it looks like that this would slightly improve the accuracy of assessor scores for the difficult decisions. Technically, it is a good solution, or it is at least a solution that would benefit the REF, but we're still saying no to this. We're not recommending it for this use in practice because the most accurate predictions from the AI leverage journal impact type data. So that would generate perverse incentives to chase specific journals. So we think that this goes against signing up to DORA, a Declaration on Research Assessment. So the overall recommendation is that the AI prediction should not be used to help make scoring decisions in the next REF in any way. So not support decision making, not replace human decision making, but instead it should be further explored through pilot testing in the next REF or REF replacement to help improve the accuracy and check technical feasibility as well. I'd like now to go through the technical background of the decision, or a little bit of it anyway. A question that we were asked in the focus group sometimes was, could we have made the predictions more accurate? And the answer is always yes for this kind of exercise. But we did try all the methods suggested by the literature review and more. We invented our own. And we did achieve by far the highest accuracy for any task of this nature. This is primarily statistical prediction tasks rather than AI prediction at this level anyway. And we think that very high accuracy for the inputs that are available at the moment, it would be difficult. And the AI is essentially not technically possible of challenging the accuracy of human experts at the moment. And the reason is that each REF subpanel member has a lifetime of experience doing research, has a lifetime of reading knowledge, academic knowledge, reading and understanding papers, for example, and a lifetime of discussing with other members of the community. So it's built up a deep understanding of their research area. And on top of that, they get to read the full text of REF papers, and they get scores for these various different REF papers. And then in order to make a judgment about one REF article, they can read and understand the full text, and then they make their score. So in contrast, the AI system, its advantage is that it gets the ability to ingest bibliometric information on a scale that the human wouldn't be able to process. But the disadvantage is it can't access the full text of papers at the moment, so it only gets the metadata of papers, title, abstract, keywords. So it has a much shallower pass of the data, and also it doesn't have the understanding, the lifetime's experience understanding to make sense of the data, essentially. So based on this limited input, it has to pick up the metadata of a ref article and decide what score to give the output. So it has a difficult task. On this basis, I think it's not surprising that the AI system doesn't come anywhere close to challenging a human level accuracy. So here I'm assuming that the humans are always accurate and get the right score. So this leads on to the question of what exactly are the inputs for the AI system. So I'll just list them here. So article impact, so the citation count, field and year normalized citation counts as an assessment of scientific impact. The size of the research team producing the research. So this is known to associate with the quality. Again, statistically associate, it's not a guarantee. The track record of the research team, so the number of articles produced and the average citation rate of the articles produced. 2 document properties, the readability of the abstract and the number of pages. So the red ones here are things that we added after the start of the project. So that makes a little bit of a difference to the interpretation of the findings if you're a machine learning person. And the journal prestige, we used something like the journal impact factor, but we used a statistically better version. And we also inputted the title and keywords, words and phrases, and journal names as well. So the words and phrases in the title and keywords and abstract, the main part of the input that tell the AI anything about what's actually researched, so the topic that's researched. Otherwise, it's just very surface level information. So based on all this information, the AI has to guess what human assessor would score an article. So how accurate were the predictions? So in terms of numbers, for the most accurate 8 unit of assessments, the prediction accuracy was between 65 and 75%, depending on unit of assessment. So this seems not very high, but if we aggregate across a unit of assessment within individual institutions, then the total score correlations between the human and computer were up to 0.998. So that's very high total score correlations, but average score correlations, so the average score per article per institution, reached as high as 0.906. So lower, still high for correlations, but both imperfect. And we showed these results to the focus group members, and essentially almost all of them were unhappy with the score shifts, even for the accurate unit of assessments. And this graph tries to explain why the sub-panel members were unhappy with the score shifts. This is Unit of Assessment 1, Clinical Medicine. This graph shows the change in the league table ranking of institutions based on their ref score. So the tables universities seem to construct for each unit of assessment immediately once they got the results, despite being told not to. Here, if I can explain the graph, this little dot here, this is a higher educational institution, and it's on the blue line. This is the average rank change of institutions based on replacing some of the human scores with AI prediction. And if it's on the 0 line, it means that there's no difference. And we ran 10 different tests for this graph, and the blue line is the average of the 10 tests. This institution, it never changed its rank. It was always in the same rank in all 10 iterations of the system. But every other institution changed its rank at least once. And the institutions on the left here, they tend to lose out from the AI. When the human scores replaced with predictions, then they tend to be ranked lower in the league tables. On the right hand side, the institutions tend to gain from the HI, so that they tend to rise up the league table. So we showed these graphs to the ref subpanel members, and the majority were unhappy with this level of risk. So some were prepared to take this risk in return for the labour saving, but the majority thought that the risk was not worth the labour saving. Details on the strategies used for the AI to replace humans. So we tried the classical machine learning strategy, which is to have humans predict some of the articles and the computer predict the rest. So this would give a labour saving of about 12,600 articles in the main strategy, but gives score shifts that are too large. And the second strategy we tried, two versions we tried of this, essentially it's prediction by probability. So we get the AI system to identify articles that it can predict with a high degree of confidence, and we picked 85%. So we would only accept the predictions where the AI system is 85% sure of having the correct answer. This would give a much smaller labour saving. But again, the score shifts are still too large for some institutions. For the smaller institutions, relatively large score shift from this system. So that's still not recommended. And then the inform but not replace strategy. So we give the AI predictions to the subpanels if they want them and allow them to use them to inform their final decision. For example, they might use them to reduce the amount of human input for the high probability predictions, or they might use them as a tiebreaker for difficult cases, or they might use them for mopping up at the end. So some subpanels reported that there were some articles that were very difficult to classify, interdisciplinary research, and they were not confident of their scores for them at the end. So the AI might help with this because it can give interdisciplinary input. So no labour saving, but slightly improved accuracy. And again, we didn't recommend this on balance because of the perverse incentives to publish in prestigious journals, despite the fact that they don't guarantee a 4-star in the AI or in by the human assessment. It's still a perverse incentive to publish in them. So the strategy we've recommended is the pilot testing to check the technical feasibility of the system and to provide an incentive for improving the accuracy of the system as well. So particularly we need full article text in a clean version for the machine learning. At the moment, most ref articles, although they are available full text on the public web, they're not available in a clean version that is relatively easy to read by a computer. So they're not useful inputs for the AI. Any questions? Happy to answer now or by email later. And don't forget to check out the website for the additional recommendations and 13 supplementary analyses of the REF 2021 data.